Hey everyone, let me take a look at this problem from section 3.4 in Achieve. I think it's number 5. I'm just going to do it right from Achieve. Hopefully you can see the screen there with the question and the graph. We have a graph that's the distance S of t from the origin as a function of time for a car trip. And so you can see the x-axis here is the time in hours, h in hours, and the vertical axis is the distance in kilometers from the origin or from a fixed point, essentially. Find the average velocity over the time interval from 0 to 1/2 hour, right? 0 to 1/2 hour, and then give your answers a whole or exact number. So if you look at the graph over the first half hour, we start at a distance of 0 kilometers from the origin. After half an hour, we're 50 kilometers from the origin. So we've traveled a total of 50 kilometers in half an hour. If you take 50 kilometers and divide it by that half hour, that's the average velocity. It's just the distance traveled divided by time. That's the average velocity. So 50 divided by 0.5 is 100, and that's what we're going to type in here. Now, keep in mind that as the car was traveling over that first half hour, its speed was not constant. It was not a constant 100 kilometers, in this case, per hour. You can see initially the slope of the line is very close to 0, and then it increases as we come up. So this car is basically accelerating over that first half hour, just speeding up, if you will. Okay, but the average velocity, right, not the instantaneous velocity. Instantaneous velocity, or the velocity of the car, is changing constantly over that first half hour interval. Now, what's the average velocity over the interval from 0.5 to 1 hours? Well, from 0.5 to 1, now we're traveling from 50 to 100 kilometers. That's a total distance of what? 50 kilometers again, over a time of what? Half an hour. So again, 50 kilometers divided by half an hour, that again is going to be 100 kilometers per hour. Okay. Again, notice the instantaneous velocity over the second half hour, from a half hour to 1 hour, is changing, right? Initially, the speed here is some positive number that's probably is greater than 100 kilometers per hour. But then over time, what the slope is getting smaller, going back to 0. So the car is slowing down essentially over this. So speeding up, accelerating from the first half hour, and then slowing down the second half hour. Find the average velocity over the interval from 1 to 1.5. So from 1 to 1.5, notice the distance remains the same, 100 always. So basically for that half hour from 1 to 0.5, the car is just either, parked somewhere. Maybe they're having lunch. I don't know, right? Or maybe they're driving in a circle around the origin. So their distance is always the same. I don't know, but it's the same. And so I guess we're going to assume here that we can't do the little circle situation I described. We've got to be thinking about straight line motion, obviously, to be able to answer the question correctly. So from 1 to 1.5, the distance traveled is 0 over that half mile. Well, 0 divided by 1/2 is indeed 0. Okay. Notice that when I said it traveled 50 kilometers, I'm taking 50 minus 0, I'm getting positive 50. In other words, it's getting further away from the origin for the first half hour. Same for the second half hour, right? 100 minus 50 is 50 kilometers. The third half hour here, no change in distance. Now, look at this fourth half hour, from 1.5 to 2 hours. The distance goes from 100 to 50. What if we just wanted the average speed from 1.5 to 2 over this interval now? Well, the distance traveled is now negative 50, right? Because we're going from 100 down to 50, the distance is decreasing. So we need that negative there. In fact, if you're finding the average velocity, it's just the slope of the line connecting these 2 points, and at the point, 1.5 comma 100 to the point 2 comma 50, and that's going to have a line that has a negative slope. So slope is indeed the velocity in this case. So it's going to be negative 50 divided by half, so a negative 100 would be the velocity from 1.5 to 2, the average velocity from 1.5 to 2 hours. Down here, they want the average velocity from 1 to 2. Well, if I go from 1 to 2, at 1, I'm 100 kilometers at 1 hour. At 2, I'm 50, right, kilometers. Well, 50 minus 100 is negative 50 divided by what? A total time of 1 hour, right? From 1 to 2 hours. 2 minus 1 is 1. So I'm going to have negative 50 divided by 1, which is negative 50. So the negative is important because it is indicating essentially what? From 1.5 to 2 hours, the car is coming back towards the origin, coming back towards the origin. And then after 2 hours, it's moving back away again. Okay. And so that's the way to correctly interpret this graph and to answer these questions. So hopefully that helps with this. And if you have questions about this, let me know.